We're back at another episode of Problem Solved. What's our topic today?
Yeah, Jake, we're going to talk about an F5 startup using closed loop operation today.
All right, let's do this. All right, let's dive into it. What are the basic requirements for this F5 startup?
Yeah, Jake, similar to our startup video with the S6 drive, we'll kind of need our 5 basic components to start up a closed loop drive with an F5. We need our AC incoming power, our KEB F5 drive, a motor, a feedback system for speed control, and our programming software to set up the drive. We're working with our F5 desk demo today, and on the demo we have our AC incoming power that goes into our F5 KEB drive. The KEB drive is powering our KEB asynchronous induction motor. The induction motor is fitted with an incremental encoder, which is connected via our green cable here for our feedback system. And we also have our blue USB to serial converter, which is connecting to our COMBIVIS 6 software on our local PC.
Now that we have the hardware requirements down, can you walk us through the steps to program the F5 drive for closed loop operation?
Of course, let's do it. I started off by connecting my KEB F5 drive to my local PC using our KEB USB to serial converter. I've opened COMBIVIS 6 on my PC, scanned for my device, and now we're ready to begin programming via COMBIVIS 6. So let's get to it. I have already created a closed loop startup for F5 parameter list, which is shown here on the left side under the navigator window. Unlike the S6 drive, the F5 drive does not have integrated programming wizards, and instead the programming is strictly parameter based. Just for reference, this parameter list was created in accordance with the F5 application manual, which is available to customers who use the free registration of COMBIVIS 6 on our keb.de webpage. Opening the parameter list, we see a list populated with parameters and their desired program values. Looking at the columns in the parameter list, we have our read-write indicator, ID text, the parameter name, the offline value column, which represents the desired value we are writing in our program, the online value column. We're going to ignore this column at the moment, but this displays the active parameter value inside a connected KEB drive. And the comment column, this allows for user comments and notes. Breaking down this parameter list, we can see most of the basic 10 steps that help us set up the F5 for closed loop operation. Before starting step 1, however, we must ensure that the F5 drive is disabled or is in an NOP state. Then, beginning with step 1, we set our control type to the value 4. This essentially sets the drive operation for an induction motor and sets the speed range of up to 4,000 RPM maximum. Step 2 of the parameter list loads factory default settings to ensure we are starting our parameterization from scratch. Step 3 of the startup sets the drive into closed loop control with encoder feedback, and step 4 then sets the feedback device to encoder 1. In step 5, we are going to set the pulses per revolution, or PPR, of the incremental encoder, which is 2500 for this particular encoder device. For step 6, we're going to be inputting our motor rated data, which would be obtained from the motor nameplate or a motor specification sheet from the manufacturer. We require the rated current, rated speed, rated voltage, rated power factor, and rated frequency. The stator resistance, sigma inductance, rotor resistance, and head inductance will be computed shortly via the motor identification in step 9. In step 7, we are going to modify a few parameters that are very important for optimized performance in closed loop operation using the motor model. These parameters help set proper flux control and magnetization buildup and allow the drive to calculate dead time characteristics and motor dependent data. Moving on to step 8, we will set our desired maximum speed, and for this test I will set the value of that maximum speed to 1000 RPM. Enter. Now that we have finished setting step 8, we are going to want to download our program values into the F5 drive. Essentially what we are wanting to do is to push the offline values that we have programmed into the online values of the drive. To do this, we can go up here to this green downward arrow which says download list to device. We will click that. It asks, would you like to start the download? We will click yes, and now this will program our drive via this download. And once that's successful, we have programmed our drive, but we are not quite done yet. Step 9 of our startup procedure is actually to perform an auto identification for the motor, or a motor identification. To do this, we will go back to our Drive tab, and then we will go into the Online Wizards tab of the drive. And if it's not already selected, we will want to make sure to select Motor Ident on the left. And when you select the Motor Ident tab, our Motor Identification Wizard window populates the screen. We're going to jump right to Box 2, Type Plate, since the drive was already adjusted and programmed via the program download we just did. In the Type Plate, we are going to want to confirm our motor nameplate data that is actually on the physical motor that we are working with. This data should be accurate since we programmed it via the download we just did, but it's good to do a second verification here. Once we verify that this type plate data is accurate for the motor we're running, we can start the identification. I usually click the down arrow and select Auto Ident with Move. Now this is only to be used if a motor is completely unloaded and uncoupled from any other load. If your motor is loaded or coupled to any other mechanical object, it is best to use Auto Ident without Move to ensure the best possible identification. So selecting Auto Ident with Move in this case, a pop-up appears and allows us to again confirm our motor nameplate data, which then we will click OK. The actual value source or speed feedback is set to encoder channel 1, which is what we want, so we will click OK here. This pop-up asks us to start identification. During the identification, the motor may move and you may hear audible noises of varying frequency, which is completely normal for the identification process. The identification may take anywhere from 30 seconds up to a couple minutes depending on the system. So we will click yes or OK. So now we will set our control release, which we have set, and now we will click OK and our identification will begin. We will reset our control release. And that completes our motor identification in step 8 of our startup. Going back into the closed loop parameter list just for a moment, we see that the resistance and inductance values have changed in the online value column. From our motor learn, these values were learned and then modified in the drive real time. Now that we have performed our motor identification, we are ready for the final step, which is some test runs of our F5 drive and motor. For our test run, I have created a scope trace which will capture and monitor the inverter state and encoder speed of the motor. Opening that scope, we are going to be monitoring encoder 1 speed and the inverter status of the drive. Using a potentiometer connected to the analog input of the drive, we can vary the speed and perform some motor function test. So let's give this a shot and spin the motor. And that is how we start up an F5 drive in closed loop operation.
So now we've gone through the steps on how to start up an F5 drive. If you like this video, like and subscribe, follow us on social media, or go to KEBAmerica.com. And we look forward to solving more of your problems in the future. Have a great day.